So here we're going to talk about related rates the Clark way. So number one, how to work related rate problem. First, you need to find out what they want. If you don't know what they want, how in the world are you going to figure it out, right? So that's number one. Figure out what they want. Do they want the derivative with respect to t of y? They want dx dt? Do they want the side length x or y? I mean, what do they want? That's what you got to figure out first. Then you need to write down what you know. That means also drawing a picture, all right? Whether it's a triangle or a circle or a rectangle, whatever the shape is, whatever you got to draw, a ladder falling down the side of a building, whatever. Draw the picture, write down everything that you know, write down, what they want to know. All right, number three, form an equation about how they are related, okay? If we're talking about perimeter of a rectangle, well, I know this is a length, that's a width, that's a width. How are the length and the width related? 2 times L plus 2 times W is equal to the perimeter. Okay, so that's an equation that relates the length and the width with the perimeter. So that's an example. Form the equation how they are related. I want to use constants for things that are fixed values, and I want to use variables for things that are changing values, okay? So maybe if, you think about that ladder example, say you've got a ladder leaning up against a building here. So there's my ugly little ladder there. Now, as this ladder falls down, the height, if I call that value y, is changing, but maybe the 10-foot ladder is always staying the same, right? And then the x down here, this is changing, right? So as the ladder falls downward like this, the length of the ladder is fixed. That's why I use a number here to represent it. But the height of the ladder, the y, it changes, and the horizontal distance here changes as well. That's why I use the variables there, okay? So use constants where the values stay the same, and use variables like x and y where the variables are changing. So maybe you want to know like the speed at which the ladder is falling down. So dy dt, how quickly is the height changing at the ladder as time changes, okay? All right. Number 4, take the derivative implicitly with respect to time. Okay, so take the derivative implicitly with respect to time. In the last video, we had a little bit of a refresher on how to take a derivative implicitly. So run through that, and then once you have that, take all the info that you did from number 1 and number 2, finding out what they want, and write down what you know, and then plug all that information in to solve your equation. Now, let's run through an example, okay? So here's our example. Radius r of a circle is increasing at a rate of 3 centimeters per minute. Find the rate of change of the area when r is equal to 5 centimeters. Now, a lot of stuff going on in that problem. What does number 1 say to do? Number 1 says, well, find out what they want. How do I figure out what they want from a word problem? Anytime I see the word find, that is probably what you're looking for, right? So anything that comes right after that represents what they want. They want the rate of change of the area. Now, the rate of change is with respect to t, time, right? So the derivative of area with respect to time, dA dt, that's what we want. Number 2, well, I want to write down everything that I know, draw a picture if I need to. What do I know? Well, radius r of a circle is increasing, so that's positive derivative. Increasing is a positive derivative at a rate of 3 centimeters per minute. So dr, the radius with respect to time, dr dt, is equal to 3 centimeters per minute. The units are important here because you think about this is a velocity. If I'm taking the derivative, it's the units of the radius divided by the unit of time. Centimeters divided by minutes. Okay, so I'm taking the derivative with respect to time in minutes. Okay, so very important that you keep your units in the correct form here. Now, what else do I know besides this here? Well, where are your other numbers? Well, I know r equals 5 centimeters, so I can write that out too. Number 3, form an equation about how they were related. What is related? How is area related with the radius? Well, I know for a circle, area is equal to pi r squared. So here's a formula that relates the area to the radius, pi r squared. Now, number 4, take the derivative implicitly with respect to t. The derivative of a with respect to t is dA dt. Hey, that's what we want, right? How about that? Now, the derivative of pi r squared, I can take the pi out front, it's a constant, and I need to take the derivative of r squared with respect to t. d dt of r squared, remember that r is different than t, so I treat it like a chain rule. So I take the derivative of something squared is 2 times something raised to the 1 times the derivative of the inside, which is r, so that's dr dt. Now I'm going to take everything that I know and plug it in. So what do I have? dA dt is equal to pi times 2 times r. What is r? R is 5. So I'm going to plug in 5 here, 5 centimeters. And then dr dt, what is dr dt? That's 3 centimeters per minute. Okay, so what does this give me here? I have 2 times 5 times 3, which is 15 times 2, that's 30, times pi, so 30 pi. And then I have centimeters, that's centimeters squared divided by minutes. So therefore my answer, the area, which makes sense that it's centimeters squared for area, right, is growing by 30 pi centimeters squared per minute. Now, you know, if you go up to your boss and say, hello, boss, the area happens to be growing at 30 pi, your boss is going to be like, what in the world is 30 pi, dude? Tell me what it is in English. Okay, so 30 times pi, second caret button, 94.247 or 248, however you want to round it. Okay, so if you're asked to do rounded 3 decimals or whatever, go ahead and multiply it out. If it doesn't tell you, just use the exact value. Nothing wrong with that. We're around a bunch of nerds here, so it'll be okay if you just keep that nerd answer. Okay. Hopefully this video was helpful in explaining how related rates works. Okay, so this is a very basic example of setting it up the Clark way. Promise you, if you do it this way, it makes the problem way easier.